Hello everyone, so today we are going to present the experiment 5, the measurement of jet forces. Okay, so the purpose or the objective of this report is to investigate the reaction force generated by the impact of a jet of water onto various target and to compare the experimental value with the theoretical value. Okay, the experimental and theoretical value can be, and also the percentage of error can be calculated in this experiment. The theoretical value are dependent upon the weights, and the experimental forces are dependent on flow rate, nozzle exit velocity, and impact velocity.
Hi and Assalamualaikum. Today I'm going to present about objective, theory, methodology, discussion and conclusion. For the objective is to compare the force applied with the theoretical value by a fluid jet impinging on a flat plate or a hemispherical face.
For the introduction, we have to know that moving fluid, whether it's a natural or artificial systems, may exert forces on objects in contact with it. To analyze fluid motion, a finite region of the fluid called volume control. Control volume is usually selected, and the gross effects of the flow, such as its force or torque or on an object, is determined by calculating the net mass, right, that flows into and out of the control volume. These forces can be determined, as in fluid mechanics, by the use of Newton's second law or by the momentum equation. The force exerted by a jet of fluid on a flat or curved surface can be resolved by applying momentum equation. The study of these forces is essential to the study of fluid mechanics and hydraulic machinery.
For the theory, a jet of fluid when impinging upon a plate or a hemispherical surface generate a force due to change of momentum of the fluid according to Newton's second law of motion. For example, when a velocity of water from jet nozzle with diameter strike on a flat plate or a hemispherical surface, the rate of change of momentum produced and its magnitude is the same with the force exerted on the surface of the flat plate or hemispherical surface to support the water jet. The force generated by a jet of water when it strikes depends on the shape of the surface, which is flat flat plate or hemispherical surface. Figure 1 is jet of fluid strike a flat plate. Figure 2 is jet of fluid strike a hemispherical surface. Figure 1 and 2 depict a jet of fluid issued from a nozzle of diameter, moving vertically upward with velocity and strike a flat plate and hemispherical surface, respectively. The jet is deflected by the surface of flat plate or hemispherical surface through an angle and leave the surface with velocity. The theoretical generated when the jet of fluid strikes a flat plate is 1. Equation 1 can be written as F equals to rho AV V1 square. For the hemispherical surface, the theoretical generator is rho F equals to rho AV1 square minus rho AV2 square cos theta. The angle equals to 180 degree. So V2 equals to minus V1. Equation 3 can be written as F equals to 2 rho A V1 square, where F is theoretical force exerted on the flat plate or hemispherical surface. A is a cross-sectional area of nozzle. Rho is density of water. Theta is the angle of water flow after impact on the flat plate or hemispherical surface. V1 is velocity of water jet before impact on the flat plate or hemispherical surface, or V2 is velocity of water jet after impact on the flat plate or hemispherical surface. For the methodology, the apparatus that we use is weight position, deflector, nozzle, lever mechanism, tank, water supply, water drain, main switch box, flow control valve, volumetric measuring tank, and sliding valve. For the methodology, for the step 1 is the test deflector, which is flat plate, was assembled. Next, the pointer was set to 0, which is 0 notch, by adjusting the screw at lever mechanism and do not place weight on the lever mechanism. Now, step 3 is the pump will be turned on with the main switch. Next, flow control valve need to be opened slowly and the desired weight will be put on the lever mechanism while adjust the flow control valve. The pointer at lever mechanism is at 0 notch. For the fifth step is the sliding valve will be closed and determine the flow rate of water by recording the time required to fill up 3 liter water in volumetric measuring tank. Next step is sliding valve will be opened and repeat step 4 and 5 by increasing the desired weight on the lever mechanism until flow rate valve fully open. Next, the main switch and the pump will be turned off while open the sliding valve and close the flow control valve. The last step is the weight on the lever will be removed and the reflector will be changed from flat plate to hemispherical surface and repeat step 2 to 7.
Okay, Assalamualaikum. My name is Shafiq Inish, and this is the results that we get from this experiment. So we are using the density of water that is 100,000 kilogram per meter cube, and the diameter of the nozzle is 0.01 meter. So this is our data for the flat plate. And this is our data for table 2, that is data for hemispherical surface. And this, I will proceed to our discussion. So first of all, we must plot a graph of log FMEA versus log V for both the flat plane and hemispherical surface on the surface of the graph. So on the same graph, on the same surface. So this we will calculate in the table that we're using log FMEA and log V. So this is for flat plate and this is for hemispherical surface. As you can see, this is the graph that we get from our table. Then we plot. As you can see, flat plate is under hemispherical plate. The blue one is flat plate, the red one is hemispherical plate. So, estimate the slope of the graph for both the flat plate and hemispherical surface and compare with the theoretical value as shown in equation 2, equation 4 respectively. And we must see the difference. So for first of all, we use the slope of the graph for both flat plate and hemispherical surface or on the linear graph. So by logging both sides of the theoretical equation for both the flat plate and hemispherical surface, we are able to get this one. This is the second. And this is for hemispherical surface, as you can see. And as you can see, the equation above is similar equals to y equal mx plus c, and as you will know, m will be the slope, c will be the y-intercept, and y-x is the coordinate. So for the flat plate is the m of the slope is 1.69, and for hemispherical surface is 1.90. As you can see, there's a difference between the value from the slope in the graph and the theoretical force for hemisphere and flat plate. This is because there is difference in the force impact toward the flat surfaces due to the different angle of the water impaction, causing the value of the slope in graph is different than theoretical value. And the second question is, we must estimate the y-intercept ratio of hemispherical surface to flat plate, and we must compare the theoretical ratio as we deduce from equation to equation 4. So this is the flat plate that we got. The y-intercept is negative 0.9226. We use the same equation, that is y equal mx plus c. And for hemispherical surface also, we use the same method, is y equal mx plus c, and we get the y-intercept, that is c. And then we must estimate the y-intercept ratio. Then you can see the average theoretical force is 2.27362 for flat plate, and hemispherical plate is 4.4516. In this situation, there will be minor and major losses of the fluid when we going through the pipe and striking the plate. So there is the difference between theory value and measured value. So compare the force exerted on the hemispherical surface with one on the flat plate, which one is greater and why. So we must compare both forces. So from the experiment, we can see that the force exerted on the hemispherical surface plate is higher due to momentum produced, which is higher than the flat plate. The force exerted on hemispherical surface plate is greater than flat plate because hemispherical plate lies on the behavior of water jet when it strikes the flat surface. It forms a radial shape which impinges on the inner wall of surrounding cylinder, and then it divides some of the water flowing shown in the cylinder wall and the rest following upwards. This will have the effect of producing a small momentum force in the downward direction, so reducing the net upwards force on the vane. Where the flat plate, the angle is 90 and cos 90 is equals to 0, which we get the force of the flat plate is only rho AAV squared. For the hemisphere surface is angle is 180, therefore cos 180 is equals to -1. So you get double the value, there is 2 rho AAV squared. From the equation itself, it shows that force act on hemispherical surface is 2 times greater than the flat surface. So that's all from me. Thank you. No, there is one more. Compare the percentage of relative error for both the plate. So we must compare for both the flat plate and hemispherical surface as function of jet velocity, and we must comment. Okay, first of all, the percentage of relative error for both that we get is different. So what we get is for flat plate is 20.09% and hemispherical surface is 2.14%. From this experiment, we can see that the percentage of relative error for both the flat plate and hemispherical plate surface show a fluctuation, which is from high goes to low and goes back high. The shape of the plate can be the source of error, and this is because the equation uses the angle which impact of the velocity from water to the surface of the plate, and maybe the plate is not in the perfect shape in case got incomplete sphere, and the angle will be different, resulting different force. The possible forces of error could be the spring coil. The shape of the coil must be in standard position, which is straight. If not, the velocity which is applied by the water is inaccurate. All right, thank you. That's all from me.
For the discussion, briefly discuss on factors contributing to error or inaccuracy in experimental data and the possible recommendation to improve the existing result. For the factor contributing to error is, the first one is parallax error due to the position of the eye which is not perpendicular to the scale of measurement and reading. The second one is the control valve may not be fully open, which will affect the result and cause the reading to be slightly off. Next, the spring use also may lose its elasticity, and this can cause systematic error and all reading will be wrong. Next, error in calculating due to the uncertainty in measurement as well as mistake made during calculating the result. The last one is error during the preparation of apparatus. For example, make sure no weight is placed on the lever mechanism of the deflector when setting the point to 0. The recommendation to improve result is the position of the eye must be perpendicular to the calibration to avoid parallax error. Ensure that the control valve is fully open before adding the weight. Next, check the spring before conducting the experiment and replace the spring if necessary. Next, repeat the experiment at least 3 times for each reading to get the true value by finding its average. And the last one is use plate that have a perfect shape to increase the accuracy of force exerted on the plate and thus giving a more reliable data.
Discussion number 4 suggests two applications of jet impact in industry. The number 1, hydropower plants. Turbines are utilized to generate electricity. Turbines rotate due to force exerted by one or more water jets that are directed tangentially onto the turbine's vents or buckets. The impact of water on the vent generates a torque on the wheel, causing it to rotate and generate electricity. The number 2 is the water jet cutter. Water jet cutter is capable to slice metal or other material by using the high pressure and high velocity of water jet together with abrasive substance. The process of water jet cutting is similar with water erosion found naturally but occurs with highly accelerated and concentrated.
For the conclusion, the objective of the experiment is to differentiate the value of the force exerted by a fluid jet impinging upon either a plate or a hemispherical surface with the theoretical values. We should then assume that the energy exerted by the plane is directly proportional to the water velocity that has been squared. The stress exerted on the hemispherical surface is also greater than that of the flat plate. Owing to the shape of the disc, the graph revealed that the hemispherical potential value is greater than the flat plate. This is also a value discrepancy where the real value and the potential value are discrepancies that are addressed regardless of such error. The water velocity is caused by the jet cross-sectional area, so the momentum and the velocity will rise due to the large configuration of the fluid.